Hey there, YouTube. So, as I was discussing in my previous video, as we switch over to the new CCNP Route 300-101, Cisco has moved the IPv6 around a little bit. Instead of putting that into its own separate chapter at the end of the book, they've now started sprinkling it throughout the book. So it's a little less painful to deal with when you're dealing with IPv6. I've kind of read through on this, going through the book, and it honestly it makes you want to hate life that much less, because it's a lot easier of a read and it's less dry. Overall, it's less painful. And with that, the topology I have up right now is actually the very first lab that you come in contact with in the new lab book. So as I said, you're going to be dealing a lot more with IPv6 in the new CCNP route, and this is a prime example right here. As soon as you open up the book, you get IPv6. There isn't much of it throughout the book as far as this particular one. This is just the RIPng, but there's only one lab of that. Part of this I have already configured. Routers 1 and router 3 are already set up, basic config. Router 2, I thought I would go through and get this one going, and we'll go from there. We'll get RIP Next Gen going on here, and what this particular lab is wanting to do is you're going to get some static routes and a default route. You're going to have a default route going from router 2 to router 3, and you will have a static route for router 3 pointing toward router 2, and then and we'll kind of go from there and get things up and running. Another note that I will mention with GNS3, as you see, this is actually the latest version. I just downloaded this the other day. I did complain about this a while back. I had downloaded a newer version, and it was not backwards compatible to the older versions of GNS3, which irritated me because I had all of my previous labs from 642.802 saved. That way I can go back to them and kind of go back through them and redo them. It wouldn't let me do that. It looks like now they convert them back, so it'll create a whole new file for you when you try to open up the older version. So that is finally fixed. One complaint I do have is Cisco with the 300-101 route labs. You need to have 15.0 code or greater, as opposed to the old 12.2 that we ran on a lot of the old routers and the switches and everything you had through there. With that, many of the routers that GNS3 supports do not run 15 code. The only one that I have found that runs 15 code are the 7200 routers. It's this guy right here. I got a hold of that code, downloaded it, and that appears to work okay. So the 7200, we'll edit this so I can show what I got. So 7200, it's 1524S7 is what I am actually running. And to kind of get a basic setup on these switches so it has most of the ports that I need, I have the 2 Ethernet ports on there, as well as the 4 serial ports on there and another slot. So this applies to all my switches. That way each switch will have 4 serial ports and 2 Ethernet ports. So if you're going to move up to the new code and do the 300-101 labs, you probably want to have to go over to the 7200 routers for that, and get a hold of that iOS config. I'm sorry, that iOS image. Get that, install that, and it seems like it works okay. I think it's a little overkill having to use a 7200 router for some of these labs that call for 1941 routers, but it is what it is, I guess. I mean, previous ones I used 3725 routers for 1941s and 1841. So what are you going to do, right? So enough of me blabbing. Let's get into it. As I said, router 1, router 3 already have a basic config, just IP addresses on here through the switches in here for the sake of getting these fast Ethernet ports up. So we'll jump into router 2 here, and we will get that one up and running. So first thing we need to do, I jumped in here, was getting ready to start configuring before I started recording. I haven't done anything yet. So what we're going to do is I'm going to configure the ports. So I'm going to start with the fast Ethernet. Shut it. We're going to do IPv6 address. Remember, we're dealing with IPv6 now. So instead of just IP address, it's IPv6 address. This is 2001:DB8 cafe :3::. I believe this is going to be :1/64. Alright, that one is good. Now we're going to, let's go with our serial 11. And this is the DCE, so we need to give it our clock rate command. And IPv6 address 2001 DB8 feed 1:2/64. We'll now shut that. And all these I haven't set up. Here's your main subnet here, IP address for each one here. So .1, .2. So now we'll go over to int S10 IPv6 address 2001 DB8 cafe :2:2/64. I'm going to shut that. And we also have 3 loopback addresses. One thing I forgot to put in here as I'm going through, we do apply link local address to all interfaces. So the 2 I just applied to, we actually need to apply the link local on there, and we'll also do it to these loopback addresses as well as the fast Ethernet. I'll go back in here and we will set those. So it's IPv6 address. I'll put the address in here. For router 2, that is FE80::2. And then you do a link local. That's all there is to that. If I can type. Local, and S10 IPv6 address FE80::2 link local. Now we'll go into our loopback addresses. And loopback 10 IPv6 address 2001 DB8 cafe 10:1/64 FE80::2 link local. IPv8 cafe 11:1/64 your link local. And then last but not least, loopback 12. Local, there we go. Alright, like that. So now we have IPv6 on all of our devices, and all of our interfaces should be up. So now we can do a show IPv6 interface brief. And we have our interfaces up here. Of course, we have some that are admin down because I do not have those configured or up. So we have up, 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 up. So looks like we are good there. So now our next step is we need to configure our RIP next gen. We'll go between routers 1 and 2. Kind of cool thing with the RIP next gen is instead of giving an AS number or something, we can actually give it a name of our choice. So we will do that. So before we start configuring our RIP next gen, we need to enable IPv6 routing. Routers 1 and 3, I already set this up, but I'll issue the command again on this one. All this is IPv6 unicast routing. And IPv6 is enabled for routing. So now what we need to do is give our name. And if you're wondering what it looks like, how you'll know if you don't have it enabled, if I do no IPv6 unicast routing, and I go to try to set up RIP next gen, it should complain to me. So I'll do IPv6 router RIP. We'll name it RIP next gen. IPv6 routing not enabled. So now if we do IPv6 unicast routing, and we do that again, doesn't complain to us. And I just named it RIPng. Is going to be our kind of system name for this. So one thing, if you remember from the previous 642.802, or if you're even studying new for the CCNP route, IPv6 you do not configure globally. Like if you go into router EIGRP and IPv4, you would configure it as an AS system. You don't do that with IPv6. This is all on a per interface basis. So if you want a particular routing process to run, you have to put it on the specific interfaces you want it to traverse through. So with these, we want router 1 to go over our fast Ethernet port, and we're also going to send it down the serial so it'll talk to the other router. So we'll start with our fast Ethernet port, IPv6, type. IPv6 RIP, our process name, enable. That's all there is to it. So now RIPng is running on that port. Now we go to our serial interface, S10. IPv6 RIP next gen, enable. Done. Alright, so now I got that one. So let's shoot over to router 2. Down a little bit so we can separate this out. So now we need to do IPv6 unicast routing. So that is enabled. IPv6 router RIP next gen. And now we need to apply this to our interfaces. IPv6 RIP RIPng enable. Let's go to our fast internet. And let's hit our loopbacks. What we could probably do, so we can do a range on that. I can type range. 10, 11, 12. Let's do it all three of those. IPv6 RIPng enable. Save us a little time on that. Alright. So now, let's do a show IPv6 protocols of IP protocols. And here's our process running for RIPng. As you can see, we have our process name, RIPng. And here's all of our interfaces that are currently running RIPng. We have 1.0, we have 1.1, serial interfaces, our 3 loopbacks here, and we have our fast Ethernet there. So everything is currently running on all interfaces that we need. So, next step we need to do is we're going to go over to router 3 and we're going to get our routes running between routers 2 and 3. So, let's move over to router 3. Alright. As I said, I already had IPv6 unicast routing enabled, so I will just jump into the route. So what we need to do is we're going to route our route here. So that's 1 db8 cafe, and we are going to start from feed. So that's our next hop. So we're going to route this whole cafe sort of network here and make the feed :2 our next hop. So we do IPv6 route 2001 db8 cafe : and we're actually going to do a little subnetting, and since everything is cafe here, we want to be able to route to routers 1 and router 2 subnets. And this will actually be, let's scroll this in so we can see the whole topology a little bit better. /48. Oh, hit enter too soon. I'll make it next hop, db8, feed 1, : 2. There we go. So now we have a static route pointing over that way. So now we need to point routes going the other way. Go to router 2. So now we're going to route everything pointing to router 3 as if like this was a WAN router or something. So it's going to be kind of our equivalent of a quad 0 IPv6 route. Everything, so this is all zeros with a net mask of 0. 2001 db8 feed 1, : 1. There we go. And now we need to be able to redistribute that to router 1. So what we're going to do is we will do a default information originate. So that's pushed down to router 1. So we'll go into our int s10 IPv6 RIPng default information originate. So now that will be pushed down to our router 1. We can verify that. I cannot type today. Route RIP. Let's see here. We're looking for zeros. Looks like it has not pushed through yet. There it is. Now it just showed up. So there's our route there. Excuse me. My contacts were drying out. One of them almost popped out on me. That was a wonderful feeling. Alright, so now we have that, so essentially we should be able to ping 2001 DB8, B8, work fingers, feed 1, colon, 1. There we go. So we can ping across. And essentially then this should work as well, pinging 2001 DB8 cafe 2, colon, 1. And we ping all the way across the network. So that works using the static routes. But if you have a larger topology, it wants to use a bunch of static routes. So let's get rid of those, and we have a default route that we can propagate and make that work across our network. So what we'll do is let's go into, back in router 2, we're going to get rid of that default information originate. We're going to do new, new IPv6 default information originate. Instead, we're going to do IPv6 RIPng default information only. So now, let's go back to router 1. And remember, it's going to take a little bit of time for it to show up. You have to wait things to clear out. Or, well, actually, what we can do, clear IPv6 RIPng. Now we can let that repopulate. Let that bake for a second. Alright. So we have that. So now we have our default information only, so that should be the only thing we're going to receive from router 2 to router 1. And let's look back at router 2. So a show IPv6 RIP. So we got our interfaces here. So we're still good there. And it should be good. Let's ping across. Ping 2001 DB8 feed 1. And that pings across. Now we do still have a static route on router 3. And we essentially could get rid of that. And we can make everything kind of bounce back and forth as far as sharing the routes in between it. V6 route RIP. But right now we do not have our RIP running, so all we'd have to do is just enable RIPng on router 3 and let it go through, and then we would have our full topology, everything would be converged and everything would work. It might not always work if there's another router that for some reason can't run that, or they're running other processes or something like that, then this would be the next best thing, is to have a static route pointing everything to that way. So this will give you a little bit of a crash course into the 300.101 labs. As I said, this is the first one you get dumped into is IPv6. Look, it's only RIPng, so it's not too terrible. So hopefully that's not too painful for you. Next step we're going to go into, we're going to dump into egrip again, and some of that will be fairly familiar, kind of glancing ahead throughout some of the lab book. A lot of it is the same as far as our load balancing, equal cost load balancing, unequal cost. We've got some other things in here, stub routing. A lot of that is the same. Looking further down the road, some of the other things that we have are named eGrip configuration, which is something new, as well as having IPv6. I'm sorry, having address families, which is a new thing with 15.0. So if you're doing dual stack, you can do a address family, so you can kind of take IPv4 and IPv6 interfaces and be able to assign them to a group, and then kind of push configurations out that will assign to both IPv4 and IPv6, which is kind of cool. So we'll dig into that later on. That looks like that is moving into about 4 labs down. It looks like 2-4. So now we're looking about 4 more labs. As always, thank you for watching. Like, comment, subscribe. Let me know if there's anything else that you'd like to see on here. And as always, thank you for watching.